are going to be running through these slides for the next 1 hour. The power behind the panel. The power behind the panel. We have to understand the electrical distribution in commercial building. So I would like everyone to pay attention, less distraction while we run through. So we have the course objective, why this is developed for this class. So when you, at the completion of this course, you'll be able to understand the following, understand the fundamentals of electrical. So my name is Abel Iyoriowe. I'll be taking you through this course. Sorry, I didn't introduce myself. So in the course of this class, I'm going to be asking to get to know you all that are in this class. So I'll run through the course objective, understand the fundamentals of electrical distribution system in commercial building. You'll be able to identify the components such as transformer, switchgear, panels, and circuit breakers. You'll be able to interpret electrical single line diagrams and access load requirements. You recognize safety precaution procedures, maintenance practices, and compliance standards. You apply knowledge to improve system reliability, efficiency, and operational safety. So these are the course outline, the fundamentals of electrical distribution, electrical design and load management, safety standards, and compliance. We also be talking about maintenance and troubleshooting, reliability, efficiency, and future trend. And at the end, we have the conclusion. Then you can ask your question when we are done with this slide. All right, overview of power flow from utility to end use equipment. So this is the overview. I want you to know that electricity begins at the utility grid and is stepped down through transformers for building use. It is not what you generate at this power station that gets to you as the end user. So there are things put in place to ensure that the right electricity, the right voltage value gets to you. So power enters the facility through the main switchgear, switchboard, or service entrance. So we have the distribution panels, route electricity to various circuits and equipment zones. So what this means, where in your facility or in your home, you have a what's called a distribution board where you distribute power to where it is needed, like from the circuit break, the distribution board to where you have your AC unit, your chiller, your lift. So there is a section of your facility that has that distribution panel. That is where all the equipment are fed with power. So we have the circuit breaker as well and fuses. What they do is to protect system from overloads and short circuit. If there's any fault in your building, you have the circuit breaker, which is this, that will trip whether you are there or not. The function is to protect your installation, what you have put in place. So we have the end-use equipment like lighting, HVAC, and machinery. These are what we call load. They draw power from your power system so that they can run. So without electricity, this HVAC, lighting, computer, and everything you can think about in the building will not function. You will not have water generated in your facility. So this is why you pay attention to what you are being taught today. To run through this, have where the generation station where you have your generator or your transformer. You have the power transformer, which modify the generated voltage to what is needed in the building. Just like your production, a producer have not produced anything if he has not got to the table of the consumer. So you that is producing, you are not one that I will say what you have produced is fine or is not fine. So you are producing electricity. It is the end user that will justify whether what you are producing is okay or not. So these are components put in place to ensure that electricity is delivered to your building. We have key component transformers, switchboards, panel, and breakers. I've explained to you the functions of a transformer. They step down high voltage utility power to usable building voltage level. For example, what is transmitted along the line is not fit to be used in an apartment or in a facility. The 132 kV and the 330 kV cannot be, even 11 kV cannot be used in an apartment. So we have a transformer that brings down the voltage from the higher value to a lower value that is tolerable by the users, like the 11 stroke 415 or 400 or 400 to 220 or 240. Those are the acceptable voltage value that a human being can interact with. 400 or 415 and 240, 400 for three phase, 240 for single phase, between 200 and 240 for a single phase. We have the main switchboard, distribute incoming power and serve as the central control point. So your voltage that is coming, the power that is coming, is fed to the distribution board where it is then taken to various areas in your building. You have the one for lifts, the one for AC, the one for HVAC, what's it called? Pumps, industrial borehole, and so. So they are distributed from a distribution panel. We have the circuit breaker, which I have explained to you. They make sure all your equipment are safe and the people that interact with this facility, your building, the stakeholder, everybody, they ensure that their safety is guaranteed. We have the protective relay and master monitor system. They perform and detect abnormalities. Whether you are there or you are not there, they function. So they are embedded in your installation so that they can protect the equipment of what the stakeholder have invested in and the people who interact with this building, with this facility. So that's the function of a circuit breaker. So I told you have single phase and three phase. Voltage level determines how power is distributed safely and efficiently throughout a facility. If the voltage you are producing is very high, like I said, nobody can work with 10 kV or a 33 kV. It has to be brought down to the level that the users of the building can tolerate. And such voltage levels, they are single phase and three phase. The three phase are 415 or 400, while the single phase are 200 or 240, as the case may be. Single phase systems serve light load. They are used to drive our electric bulb, computer, some AC that are not up to three phase units, and so on. While uh, a three phase motor or multi phase are used to drive industrial load like your lift. Single phase cannot drive your lift. It's the three phase put together that can drive your lift. When I mean three phase, three wires and neutral are called three phase, while a single wire and a neutral is called a single phase. No, it's not just to have them in place. You have to effectively distribute these phases. If they are not well distributed, your generator will suffer. If you overload a particular phase and the rest are not connected to anything, that alternator will be humming. It will not function well. Before you know it gets your alternator burnt and you start spending money. So ensure that these phases are well distributed across your facility. Don't overload a solar field so that the generator or your transformer can perform effectively. Load balancing ensures even power usage across all phases. If you balance your load, your generator will function well. your alternator will function well, your transformer will function well. Or you have to also ensure that regular monitoring of voltage and current flows help optimize performance and prevent costly downtime. What does this one say? When you monitor the voltage that you are generating, if it's above a certain threshold, you have to raise alarm. If you don't monitor it, you allow high voltage to come in, operate your system, and burn it. And if voltage is too low as well, it affects the operation of your equipment. If it's too high, it causes your equipment to break down. So you have to ensure you monitor and balance it up properly. We are reading and interpreting single line. So a single line diagram provides a simplified visual representation of any electrical system component and connection. So a single diagram, when you have it, it gives you an idea of what that installation is all about. So you don't need to start cracking your brain. So it's good you familiarize with yourself with a single diagram or know about it. If you have not heard about it, Google it, research it, and see. Give you an idea of how an installation can be represented or presented. They show how power flows from the utility source through transformer, panel, and distribution circuits. So you need to understand it so that you know how your power flows from the pole to the CCU, consumer control unit, from consumer control unit to the distribution board, from distribution board to various areas in your apartment. It helps understand symbols and notation. It's key to identify switches, breakers, and protection devices. So they are outlined there on that single diagram. So this diagram helps facility managers quickly trace faults. You know where your breaker is, you know which breaker is down, which equipment is not working. So through that single diagram or the installation diagram, you're able to trace where the fault is coming from, how you go about it. It gives you an overview of how that installation is presented. Calculating load capacity and distribution. Load calculation determines the total electrical demand of a facility to ensure safe and efficient power distribution. For example, many people undersize the size of their transformer or generator, even cables. If you do not know the load that those equipment are going to be supplied, you may under uh, underrepresented. So you have to know the capacity of your load. How do you determine your load? Like in your, let's say, a three-bedroom flat, or yeah, a three-bedroom flat. You have AC in the three rooms. You have water heater in the kitchen, in the bedroom, and all the three rooms. And you have other things. So put the wattage together. You know the power rating of this equipment. You put them together, aggregate them, and calculate. If, for example, at the end of the calculation, you have like 30 kilowatts of the total load in your building. So that shows that you are going to need like, if it's three phase, you are going to need like um, let's say 10, 10. You distribute that 30 into three lines, that's the three phase, 10, 10, 10. That makes it 30. From there, you are not going to tell them to get a generator of 30 kVA or 30 kilowatts. So you're going to give room for allowance so that when you eventually complete your installation, if there is need for modification or future expansion, you create around like plus or minus 10% or so of the total load that you currently have. Then you can tell them to go for like 12 kVA or 15 kVA because you have determined the load that that building requires. So when calculating, it helps you to understanding the connected and demand loads, help prevent overloading and equipment failure. If you spec it right, you won't have issue with generator shutting down because of overload, generator shutting down or cable being burned because of overload. So it gives you It helps you save cost on the long run. So you balance load distribution across phases, improve system performance and energy efficiency. If one phase is overloaded, it will be affected by that two phase, the two other lines, red, yellow, or red and blue. So ensure that the loads are distributed evenly across the phases. Regular road assessment, like I said, it gives future expansion. If, for example, you are now bringing something to add to what you currently have, you may not check what you have, what has been your trend, and then you now recommend what to be added. If you go and add a higher capacity of load, you are defeating the purpose of procuring that transformer or a generator. What you need to do, you have to ensure that you keep record of what you are with the load that you have currently, and ensure you don't overload your generator, your equipment and your cable. Accurate load analysis ensure compliance with electrical codes and support reliability. So power factor correction and energy efficiency. A power factor is a unit that has been calculated is normally 0.8, 0.8. So if the power you are having is lagging or leading, there is a method that are used to correct this issue. Either use a leading power factor or a lagging power factor. Power factor correction improve the efficiency of electrical system by reducing reactive power and minimizing energy loss. If you have more of reactive power, you inject a power factor correction. So, so we have inductive load and a capacitive load. Capacitive load is where you have these they are synonymous with fluorescent tube. So if that's what you have, it will give you a negative power factor. It starts affecting your generator. So what you need to do is to create a correction that will at least compensate for the negative feedback that the equipment is currently having or your installation is having. Installing capacitor bank or automatic correction device help maintain optimal power factor. These are methods used to make sure you have at least a clean, efficient power distribution in your facility. Efficient power management lowers utility bill. When you manage your cost, your power very well, if the power factor is well managed, you will see that your bill will start uh, going down. But if you don't manage it well, you'll be paying because you refuse to pay attention to what you are meant to do. So one of the ways to improve our power system and reduce utility is to have a capacitor bank in your facility. So those are compensating device or equipment that has been put in place alongside your installation. Most people have seen it, some have not seen it. Ensure that once it's mentioned, Google it and see, or maybe on a field trip, you will be exposed to this equipment. We have them in some of our facilities. So on the field trip, you'll be exposed to them and make sure you participate in the mastercraft program so that you can be taken to the field to see this thing live and relate with them. So integrated power factor correction with energy saving initiatives support sustainability and long-term operational efficiency. So these are the ways you can reduce costs, maximize costs, and make sure you sustain the operational efficiency. So this is the only way. We don't produce anything as facility manager. We play with figures. We play with data. So as you are keeping record of what you are doing, and being this topic being mentioned and related to what you do on a daily basis and see how you can bring down costs. One of our function is to bring down costs, not compromising standard, but delivering at a higher capacity. electrical codes, permits, and inspection requirements. Compliance with national and local electrical codes ensures safety. So when you comply with this requirement, you bring safety to your facility, to your environment, One of the things we are employed to do is to make sure our buildings is safe. Once our building is safe, people can work efficiently, people can work without fear. The turnaround will increase, the turnover will increase. So stakeholder will be happy. Our main objective is to bring profit, maximize cost and bring profit, reduce risk. So when you need to comply, it's not an option. You have to comply with industry standard. Electrical permits must be obtained before installation. You must get permission. Anybody coming to work be must show you a permit to work. What is it coming to do? That details what is coming to do. Without that, don't allow such person to start any maintenance work or any project in your facility. What this helps you to do is to help you with liability in case of anything. Because even if your facility is insured, the insurance company will ask for all of these documents. Do they comply? So if you compromise and you allow them to work, your company will not be happy with you. Proper documentation and record keeping, simplify audit and future upgrade. When you have proper documentation and record keeping, if there is any information that is required, whether you are there, you are not there, you just go to the file or where you store it, bring it out. It helps reduce the downtime and the other hinge that you may face. Collaboration with certified electrician and regulatory authorities help maintain continuous compliance and operational safety. So you don't do things in isolation. You have to collaborate with satisfied people. Any knowledge that you are not privy to have, consult people, collaborate. It makes your work easier. So we learn every day. There's no knowledge is not a monopoly. So don't feel, oh, I know it or you don't know it all. Ensure you collaborate, network, meet with people, ask questions that relates to your field. When you do that, you are guaranteed of operational efficiency and the safety. All right, common electrical hazard and preventive measure. When you know that your system is overloaded, it's because you do not, when you overload your system, it's because you don't follow electrical procedure. You don't follow electrical procedure. Overloaded circuit can cause overheating and fires. Can cause overheating and fire. All right, sorry. Overloaded circuit can cause overheating and fire. Regular loads assessment prevents excessive current draw. Two, exposed wire and poor insulation increase shock risk. Routine inspection ensure safe containment. Faulty grounding or burning can lead to danger. Can lead to dangerous voltage buildup. Proper earthing eliminates this hazard. So these are the safety measures you can take to prevent electrical hazard. For example, like the earth we talked about here, if your earth is compromised, your earthing is compromised, you have to ensure they are improved on a regular basis. If the earth is compromised, the whole installation is compromised, both human and equipment. Ensure that the value of your earthing parameters are up to industry standard. Like the earth resistivity should not be, it is assumed to be zero. When you see that it's going from 0.009 to up to 1 ohms and above, you know that something is wrong. Ensure that you treat and maintain where you have the earthing arrangement in place. Water exposure near electrical system poses severe risk. Enforce strict moisture control and isolate protocols. Don't allow electricity to come in contact with water. Water is a bad conductor of electricity. It conducts, but it's a bad conductor of electricity. Don't expose electrical circuit to water. Or when you see water leaking into your panel, raise an alarm. Stop that water from being coming in contact with electricity. Inadequate maintenance of equipment leads to arc flashes and failures. Scheduled servicing enhances system safety and reliability. When you don't maintain your equipment, you run to failure. Resistivity starts coming in. Dust particles being absorbed by this panel settle there, they start causing resistance to the flow of electricity. Arcs start building up before you have a flashover that explodes your panel. What you need to do is to make sure that if you are meant to clean, clean. If you are meant to lubricate, lubricate. If you are meant to grease, grease, so that your equipment are intact. Lockout and tagout procedures and personal protective equipment. What do you mean by lockout and tagout? These are what you do when you're carrying out major maintenance on electrical equipment so that your safety can be guaranteed and there will not be a breach somewhere. Lockouts and tagout ensures electrical systems are completely de-energized before maintenance or repair begins. So lock it, this thing is locked. When you finish, you tag out, this project has been completed. Authorized personnel must apply lock and tag to isolate energy resources and prevent accidental reactivation. When a trained person says that this place is locked, is locked, he will not go in and. But if you don't do it, if you don't put anything there to show that you are working, unknowingly someone may just come, oh, why is this thing off? They will have to close it. Maybe you are working with a live wire. What happened is accident. If you are alive to say, express what happened, good for you. Electricity is not something you play with. Ensure you lock it and hold the key. When you finish, open it and put a project completed as we are tagging out. Clear communication and documentation of lockout and tagout steps maintain accountability and worker safety. Proper PPE such as insulated gloves, arc-rated clothing, and face shields protect against electrical shock and burn. So accident is never, but you can prevent it. It's inevitable, but you can prevent it. When you are given a PPE, ensure you put them on. It's for your health and safety. Your manager might be in the office, chilling out in AC, but you are on the field. If they give you PPE, personal protective equipment, ensure you put them on so that your life can be preserved and be in safety. Regular training and audit reinforce compliance with safety protocols and reduce the risk of workplace accidents. When you train your workers, when you expose yourself to training, you know how things are being done in the industry so that you don't work in an archaic way. When you do this, you are improving on your deliverables and the safety and the equipment as well. So ensure you expose yourself to training. You can do self-development training on your feet. You can enroll like the Mastercraft program where many things will be exposed to you that you didn't know before. So regular training is key to our business. Routine inspection and predictive maintenance starts. So regular inspection helps detect wears. When you carry out inspection very well, when you are meant to do, it helps you to detect wears, corrosion, and loose connection before they cause equipment failure. So equipment don't just develop faults overnight. It's not a rocket science. You have to ensure you do inspection on a regular basis to detect any abnormalities they associated with your equipment. Thermal imaging and vibration analysis identify hidden electrical faults early, preventing costly downtime. We have thermal imagination. So when you use infrared and scope to detect what is happening in your panel that your optical eyes may not be able to see, but with the help of infrared, you see how these equipment are performing and where you have a hidden issue. So they will reveal them to you. Predictive maintenance costs uses sensors, data, and analytics to forecast when components need servicing or replacement. So technology has helped us over the years to be able to know when to carry out maintenance, like your PPN on some major equipment like your lift. So you have sensors that notify you from your phone or wherever you are that, oh, you need to carry out maintenance on this equipment instead of trying to rack your head. The sensor and the gadget will just notify you on your phone that so-so equipment, so-so maintenance is needed. So schedule testing of breakers. So ensure you kind of plan preventive maintenance on all your equipment so that they can perform optimally. A proactive maintenance plan extends equipment lifespan, reduces energy waste, and enhance overall operational efficiency. So this is how you maximize cost for your organization. Identify and corrective system faults. Like I told you earlier, constant regular monitoring of current flow and voltage level helps detect abnormalities that indicate system faults. Two, circuit breaker, relays, and protective devices should be checked to isolate and identify fault locations quickly. Use diagnostic tools such as multimeters, isolation tester, and infrared cameras to pinpoint electrical issue. Root cause analysis ensures faults are corrected at the source, preventing reoccurrence and improving system reliability. If you don't know, if you are just changing a bulb without knowing what is making that bulb to go bad, you will just be wasting money. But when you know the root cause, it could be the switch, the switch that is supplying that light. Maybe the wires are not firm. As you pull the bulb, the thing is having partial contact. Constantly, before you know your bulb is born, Oga want to change this bulb again. So you have to ensure that the root cause of any problem is dealt with before uh, uh, doing the corrective maintenance. All right, using monitoring tools and digital diagnosis. Smart meters these days and sensors provide real-time data. You know, even when you are not around, you are overseas, they relate with you in your gadgets. So you see your consumption, you see what is going on in your facility. Digital dashboards help facility managers visualize power performance and detect anomalies instantly. As the problem is occurring, you are seeing it from your phone or from your gadget. The frequency is getting too high. The frequency is getting low. What could have responsible? Maybe there is restriction of flow of fuel into my machine. So they are giving you first-hand information. Predictive analytics and AI-driven tools identify patterns that indicate potential fault or inefficiency. So these are what a digital monitoring gadget can help you to achieve. So in conclusion, integrating digital diagnosis improves accuracy, reduce downtime, and support data-driven maintenance decisions. When you have data to play with, you're able to analyze your pattern, the trend, How are we consuming our diesel? How are we using our consumables? So if you don't have data in your hands, you won't be able to make decisive decisions. So these things help you to management to make the next line of decision. Maybe over time you see that I've not really utilized my 200 kV that I have on my side. Our load has been between 80 and 120, 18 and 120. That shows that you don't need 200 kV in your estate now. When you talk of diesel, what the diesel price is all about now. So you real-time management, decision making. So that's what you present to your management. I've seen that over the last 1 month or 1 year, we have not used up to this. Because of the cost of this diesel and coal, I recommend we get a lower KVA that can reduce the consumption of our diesel. So these are the ways you bring value to your organization and ensure you reduce cost. Integrating renewable energy sources and smart meters, like the solar panel that we all know, it helps to reduce the cost of electricity. The initial cost might be high, but over the time spread it, you are really saving big for your organization. These are the things you present to your management, ways to bring down our cost. Operational cost is mainly is about 70 or so 80% of energy as power. Smart meter track real-time energy usage. I told you this before. So it helps you to monitor what you use. Like some people, before now, they used to leave their AC on, their air condition. Their fan is blowing, nobody is there. Their bulb is off, nobody is there. But with this real-time management, we will see that your bill is going higher. You're not compelling you to see it. You are seeing it from your palm. Why am I paying this much on my electricity bill? It will show you, sir, your AC was on when you were not around. Your fan was blowing when you were not around. They leave the water on. Your pumping machine was working when you were not around. It shows you where the high amount of money is coming from. Nobody will advise you. When you are not around, then you go there, switch it off, check the next month, you see that your bill has come down. This is what data-driven maintenance can help you to achieve without arguing or trying to make yourself point. These are the things you said to your organization that everybody must embrace. All right. Implementing energy management system. Energy management system, that's EMS, centralized control of electrical loads, helping optimize consumption across facility. Real-time monitoring enables quick identification of inefficiencies and corrective actions to reduce waste. So like I explained to you, when you see that when you are not you when you are not around, your bulb is on. So you introduce a sensor that says that I am here. The light should come up. If you are not there, the sensors will automatically switch off your power. So it helps you to work smartly and pocket friendly, as well as reducing your cost of managing your power system. So EMS data supports strategic decision on energy procurement, peak demand, peak demand reduction, and sustainability reporting. Like I told you, we have run this generator for between 80 kVA and 120 kVA, and we have 250 or 300 kVA. We don't need 200 kVA or 250 kVA. With this information, present it to your organization, the management, they can relate with it. You just go there, print it out from the printer, and show it to them. You don't need to start arguing. This is the real-time energy management that we need. Nobody will want to continue wasting money. They will buy your idea once it is properly presented and defended. So, like I tell my people, my student that I happen to come in contact with, our work is the will is a case that must be won. Whoever that present and defend or justify his or her claim, the accountant, you will win the case. If they see you as a cost center, nobody want to go. But if they see you as value-driven person, anything you are doing must relate to value. This is if we do this, this is the value we are going to get. I'm not saying you must buy, present it the way it is. Real-time data shows that we are underutilizing our uh, measure facility or your generator or your transformer. We don't need it. A real-time smart energy meter say we don't need it. This is the result. This is what we need now. So you do return on investment presentation. If we do this, this is what we are going to save, and this amount we are going to use to buy it. That's business case. And with time, in 2 years' time or 1.5 years' time, we'll start reaping our profit. So it's a case, not I have reported, I've complained, like most of us will say, I've complained to the management. No, it's value presentation. Present your case and the value you are going to get at the end of the presentation. Conclusion, as you have said, a well-managed electrical system is the foundation of safe, efficient, and sustainable facility operation. Nothing more. When you manage your equipment very well, you are creating a safety environment, a safe environment. The finance involved efficiently managed, and the building is sustained. When you need to carry out any maintenance work, you do because you are optimizing the cost. If you need to replace obsolete things, you replace. Understanding power flow, components, and codes ensure compliance and minimizes risk of system failure. When you stick to the standard, when the circuit breaker is bad, replace it. When a fuse is bad, replace it. Don't try to join wire together to make sure that it's supplied to that bit. No, you are doing more harm than good. So when you do this, you are creating a safe, compliance, minimize risk system failure. Enabling environment, ambient environment. The AC is not going bad because your generator is overloaded. The AC is not going bad because you have not carried out PPM on the generator or your transformer. So these are the things you must pay attention to. There is no rocket science about it. Proactive maintenance and digital monitoring enhance reliability, reduce downtime, and extend equipment lifespan. That's what I just explained to you. Real time, communicating with your gadget, your system, your installed system. And doing this, you have facts, you have data to back up your recommendations. You are not trying to work things out abstractly. You are working based on what your gadget installed and sending to you. You are collecting the data for presentation, for decision making as well, for management decision making. These are MIS gadgets that must be familiar, that you must get acquainted with. Integrating smart technologies and renewable sources prepare facilities for the energy demand of the future. If, as the diesel is going up, you do a cost-benefit analysis of procuring renewable system like the solar system, the inverter and co. Present it to them and let them analyze with what you currently have. Like some people still use fluorescent bulb, like these 18 watts and the 36 watts, whereas 10 watts or 7 watts can do the same job of illumination. So these are the things you pay attention to. Go with the latest technologies and industry trend, what is trending in the industry, so that you won't be left behind. Facility manager who master electrical distribution drive both operational excellence and strategic resilience. That's the truth. If you know how electricity is the bedrock of any successful facility manager. If electricity is good, you have achieved like 70 or 80% of the operation. Every other things follow. And then followed by water before you now start talking about cooling. If you don't have a clean electricity into your building, you run at a loss. You'll be spending more on replacement of equipment and other things because your electricity into your facility is not clean. There are methods you can use to ensure that your electricity is clean, that is being fed into your facility. Thank you for paying attention and being attentive throughout this presentation. If you have any question before, I have up to like 30 minutes now to go. If you have a question that you need answers to that others can benefit from, you can go ahead and ask your question. Thank you.
Good afternoon, Mr. Iben.
Good afternoon, sir.
Yes, sir. This is a wonderful exposure and it's been interesting. In fact, you said something last that electricity is the backbone of every facility because the truth is that once 70% is achieved, it's as good as the facility in order. Having said that, sir, you are talking about the low.
Please, may we know your name? Others.
Okay, my name is Adeyinka Adeniyi. I'm
Okay.
calling from Abuja.
All right.
All right.
Continue
Yes.
with your.
Okay. My question is, you are talking about the load balancing. Yes. Load balancing, as you have already explained, and the power factor. But then I can get the fact of that load balancing that is always for you to make sure that your load is balanced. That is, so that the voltage will not be high in one way or the other. But then, having come to power factor, I want you to give me a more practical approach because you are telling me that it's a way to correct and improve your efficient power in order to reduce your utility bills. As a facility manager, how do I do that for introduce that power factor? Because to reduce utility costs, electricity bill is very, very key. I want you to give me more practical way to do about that. In load balancing, I understand, but the power factor itself, can you shed more light on that, sir? Thank you.
Okay. Any other question, please?
There's a question on the group, Mr. Abel, on the chat.
Okay. Okay. That's from this is Adeleke, right? Thank you for the class. I would like your expert's advice on or take on this scenario of mine. I manage a facility where 6 check meters was installed. Okay, was installed to cover for each floor, and I was made to understand that there are some areas, most likely the common areas, is not metered. At the end of every month, when NEPA guys comes to take reading, I also read the 6 check meters, but the outcome confuses me. All right. Since the check meter covers for NEPA and GEN usage, it is expected that the total reading should be higher than the NEPA. Okay. Okay. My end, the total check meter reading is always less than the NEPA. All right. All right. Okay. I know where you're going to. I will come to your question. Mr. Day, for the power factor, uh, yeah, like it depends on your loading approach. Like some facility has more of lighting, like the fluorescent in their system, and they are running on let's say, a higher generator. So that fluorescent would not really draw power from the generator. That means that facility is running on a very light load. What you need, and there will be this voltage high. So what you need in such scenario is to look for, they call it a load bank, at least to load that transformer or your generator to at least 45%. Because if you do not load it to a certain level, your bulb will be going bad. Every now and then you start replacing bulb. On the other hand, if you are on a very high demand area, more of inductive load. When I say inductive load, like chillers, the lift, and so. And you also need a compensating factor that will, at least, we call it a reactive device, a reactor, where you have the power, where you have the capacitor bank. If you go to most industries, there's a room or a section that is dedicated for capacitors. So what they do is to help you switch on this high demand load. Instead of them picking on their own, they will help you to switch it up because they have they store charges, they store electricity. So they help you to switch it on instead of those equipment coming on their own one after the other. That's why when your capacitor is bad on your AC, the AC will not come up with the current power arrangement that you have in your place. The same thing with your fan, your ceiling fan. If a capacitor is bad there, it will not come up. The capacitor helps you to speed up the running of uh, that equipment. What that does, instead of starting with a higher demand uh, power, you are starting with a very little power, and in the return, you are saving cost for your building. Are you getting me? Like your fan in the house, if the capacitor is bad, maybe
Okay.
that maybe that your 3 kVA generator will not be able to start. You need like 6 of that to start just a fan in your house. But if the
Mm-hmm.
capacitor is there, the capacitor helps to start it up within a short time and set it
Okay.
on a running mode. That is the practical approach I believe I can. I don't know if you understand what I'm saying.
Yes, I'm getting you. I'm getting you.
All right, that is that for compensating the power factor.
Okay. That is your capacitor if it is good. Instead of maybe probably you have 3 kV and maybe you need 6 kV to start it up, but because of the capacitor, it's good.
Yeah, you need
You
just
can,
a very little amount of energy to start it up, to put it in operation.
oh, and that indirectly reduce your cost of.
Your bill, yeah, at the end of the month.
Yeah. Okay, okay. I can get the reason now.
All right.
It's okay.
For the other one that said meter configuration, it's about configuration. We have multiplying factor for our meters. So maybe the NEPA meter is not programmed the way your meter is programmed. They are not from the same factory. They are not from the same manufacturer. So you are not expected to get the same reading. So that's the discrepancies there. If it's the same company that installed the maximum demand meter and the check meter, I may be a kind of closeness. But if it's not the same company, there will be a disparity in the figures. But what you should know is that um, for the common areas, there are losses along the way as power is being transmitted along the various places. There are losses. So what compensates for these losses? Maybe that's why you're having a lesser value also than what you have on the maximum demand meter. Is that taken? Hello? Hello? Are we still together?
Yes,
Yes,
sir.
Yeah.
I can hear you. Yes, we
And
can
the
hear
person
you.
that typed that question, I've answered you. Did you get my explanation, please? Okay, let's move on. Okay, all right, all right, all right, all right. Okay. Any other question before we round it up?
Yeah.
Yeah, good
Then
afternoon, sir. Good afternoon, everyone.
Yeah, ask your question, please.
Okay, I'm Mr. Daniel by name. I
Okay.
just want to know, in case of maybe as a newly employed or contracted facility manager, maybe in a residential facility where people are already occupying there before you came in. So, and you need to know the the total energy consumption so that you can either, like maybe you want to know that they are
Oversizing or
underusing
undersizing.
they are whether they are whether they are overusing the power system or underusing it. So, and you cannot go to their different apartments to start looking for the loads that are there. Is there any way you can calculate to know the total load that is in the facility?
Yeah.
Thank you.
You don't need to go to like is it 3 bedroom flats, 4 bedroom, as the case may be? So you have to have a standard for the estate, like AC, for example, are the major equipment that consumes electricity in the facility. You have to use a standard. Okay, 3 bedroom flat will have like 4 AC if they, or let's say 5 AC if they want to put in the kitchen as well. So you know the rating of that AC. It can be similar to all other apartments. So get the rating if it's a 5 unit apartment or whatever. So whatever you have in that sample flat or apartment, use it. Use it to produce what your total load could be, plus or minus 5% could be, and use that one to determine the size of the generator or the equipment that will be required for the facility. Or you can elsewhere approach them to do is a kind of you sensitize them that this is the reason why you want to carry out load analysis. It's for their own benefit and for your own too to make your work easier. So you let them know, inform them ahead of time that this is what I want to do for this period. It could be 1 month, could be 3 months. You are taking data, you are gathering data. You also use it to advise them on how they can better manage their equipment. So you engage them, not you doing it in isolation. You have to engage the community or the facility you are working for so that they will know the value you have. Like I said, you are coming with a value. You are bringing in value. So communicate value to them. I believe, if the first option cannot work for you, I believe this one that I just say you should engage everybody who work for you. Let's start from there. Thank you. All right, my
Thank
time
you.
is up
Thank you.
now. If you have any question relating to what we have just discussed, you can reach out to the the training manager, that's Miss Miracle. She can get in touch with me. I'll give you my phone number if you want to have a direct contact for question that you need answers to. My number is 080 35 10 4509. My name is Abel. Is that taken? 080 35 10 4509. Have we all gotten the number? I need response. Hello?
We've got it, the number. It's
All
okay.
right. Thank you so much for your time and patience. It was really an exciting class. Have a lovely day. Thank you.
You're
Thank you
welcome.
very much. All right.
Thank you.